I would like to welcome everyone in the room and everyone online to day 2 of the 23rd Annual Online Dispute Resolution Forum of the National Center for Technology and Dispute Resolution here at Cyberjustice Lab, the University of Montreal. I want to begin once again by thanking our hosts for their fabulous hospitality and the heavy lifting that they did in organizing this year's forum. We bounce around the world to be located in different spots, and we're able to do that because of the hard work, the passion, and the commitment of hosts wherever we go, and this year has been no different. Thank you to the Cyberjustice Lab, to Kareem, to Nicholas, Alexi, Valentine, and Sylvan, and many incredible students who helped make the stay so far be so smooth. And thanks as well goes to the intrepid NTCDR Program Planning Committee. My name is Leah Wing, for those of you that don't know me, and I'm the director of the center. One of the most exciting aspects of the disruptive nature of technology is the innovations that can result in the delivery of substantive benefits for humanity, such as increasing access to empowered decision-making and access to justice. Another exciting attribute is the breaking down of professional and disciplinary boundaries and disciplinary silos. The processes through which we research, experiment, and create, and with whom we do that work in order to tackle society's problems. For over 2 decades, the ODR Forum has been a venue for cultivating cross-disciplinary relationships and showcasing innovations that are born of just such relationships. Our gathering is an opportunity to highlight the movement from imagination to manifestation and to stimulate collaboration on the next groundbreaking ideas. And this forum is no different. Yesterday's panels and informal exchanges throughout the day and in the evening bore that out. And today we can look forward to more of the same, with our distinguished keynote and 4 panels of speakers who will focus on AI and ODR today, the new contributions as well as the threats to access to justice. The potential of AI is already bearing fruit, and we have some important conversations ahead of us on ensuring that the roots are well nourished without bias and that the manna is shared fairly. I hope you enjoyed today and are inspired to continue innovating for effective dispute handling. However, before we move to today's program, let's take a moment to speak of what you can look forward to next year. And since our host for the 2024 forum, Center Fellows Bennett Global, will not be here at the close of today because of his flight arrangements, I'm going to turn it over to him to say just a few words. Spennick, are you here?
Yeah.
Thank you, please.
Okay, thank you very much. I must say that...
Spennick, we have a microphone heading your way.
Great, perfect.
Just for people online.
Thank you, Nicola. Thank you. Okay, so hello everybody, and I will be very short. I have been enjoying very much this venue, and I look forward to next year. And next year we are hosting similar event in Prague. It will be in the very beginning of June. So I think that 5th and 6th of June. It's also in the middle of the week, so that those of you who come from abroad can enjoy a few more days in Prague. And I think we would like to organize similarly inspiring venue as our friends has managed so far here in Montreal. I think that in 1 year time, possibly the time will be either similarly exciting or even more exciting than...
The microphone is up.
Okay, but it's... Oh, okay. So, all right, so fine. Anyway, so I will not repeat what I said. And I think that there will be a website probably from the beginning of January. I hope you will get noticed, and we look forward very much to seeing you in Prague. We will invite also more people from Europe, possibly also from other parts of the world. So hopefully it will be an exciting comparison, and I must say that I already look forward to continuing our discussions from here. So we look forward to seeing you all in Prague in June next year. Thank you.
Thank you, Zdeněk. It takes a lot of work to pull this off. Zdeněk's done it once before, so we're fortunate that he'll host us in Prague once again. I will also say keep an eye on odr.info, which is the center website. We'll certainly place a link to the website and inform you of the dates. So next, it's my pleasure to introduce our keynote speaker, Professor Laurent Charlin, who will present on artificial intelligence and ODR, setting the stage for the rest of the day. He's an associate professor at HEC Montreal, which is the University of Montreal's business school, and he holds a PhD from the machine learning group at the University of Toronto. And our host, Nicholas, will assist with questions and answers, part of the program at the end of the talk. So please help me to welcome Professor Laurent Charlin.
All right, thank you for the kind introduction. I'm very happy to be here and to be able to kick off this day. So my presentation, which I think should appear shortly, will be on AI. So this is how I'm hoping to spark some ideas, and I think some of the discussions from the panel and the topics that will be discussed later on seem fascinating to me. All right. So I see it here and it's up here. Thank you very much. Yeah. Okay, so before starting talks on, or when I start talks on AI, often I like to start by showing some examples of some of the recent progresses of AI. One thing that I particularly enjoy is, is this picture here. Sorry, there's supposed to be an animation. So the idea here is that all of these pictures were generated by a computer, right? But if I had not told you this ahead of time, this might be quite surprising to you. And if I use some of these pictures, say in a news article or online, we'd probably never second guess that these aren't actually real people. Okay? And so the photorealism here is quite impressive. What I found further impressive is how far we've gotten. So this is, this shows you the sort of pictures we could generate back in 2014. They were grainy, they were black and white. It looked like they were really from maybe 100 years ago. And very quickly, colors came in, the pictures got higher resolutions, we got finer details, up to a point where around 6 years ago, you basically had, perfect quality pictures, things you could really pass off as real pictures. Of course, this was around 2018. Things have also moved from then, and now I think we're at a stage where we can effectively not only generate things like faces of people, but we can actually control this generation. So here's an example that I think is a little bit funny. So this particular person, which you see at the bottom left, is sort of a time traveler, and they portray themselves in various historical scenes. Of course, these are made up by the AI. And so at the bottom, you have this person with the Trojan horse. And at the top, it looks like he's in the ring with Muhammad Ali. Okay? And if you actually go to this person's website, he's got a recent one where he now has videos of him speaking with Albert Einstein. Okay? Again, these are all completely generated. So here's the agenda, the sort of 3 parts of my talk that I'll discuss today. First of all, I'll describe AI as being the latest tool that we humans have invented, right? Throughout humanity, we've always been building, developing, and discovering tools, and AI is just the latest technology tool that we're discovering or developing. And I'll talk a little bit about how we build and develop modern AI systems, and in the last part, I'll look forward a little bit, try to think of where some of these AI systems might be going, talk about current limitations of these AI systems, and maybe leave you on a few notes for what I see coming in the years to come. Okay? Okay, so AI is really just a tool, right? We've always been inventing tools. Here's a particular tool we've invented around the 1750s. This is a steam engine. I think this particular version is a Watt steam engine. It was invented around the 1750s. And if you think, and if you go back, sort of if you do this little mental game where you go back to the 1750s and you were presented with this machine, it's likely that you could think of immediate usages for them, right? You could say, okay, this can really sort of it's big, but it could sort of be brought to different places, and maybe I can build mills around it, and so I might not need, wind power anymore or the power of rivers. I can really build these mills wherever I want. Then you might have been able to say, okay, fast forward maybe a few years, if I can miniaturize this particular device, which is right now as big as a room, then maybe I could get it on carriages, right? And so I don't need horses to pull my carriages anymore. And effectively, I have something that looks like what we'd call today an automobile or a car, right? And then I would argue that there's probably things you might not have been able to think right off the top of your head when you saw this in the 1750s, because they required a second technology to be built and be used in combination with this one. Think of a steam locomotive, right? A steam locomotive is only helpful if you have a network of railroads that allows you to bring freight from one place to the other. And I think AI in many ways resembles this. We are seeing now these AI systems, they are evolving. We can think of how we might use them now. We can think maybe of how we might use them in the next few months, or maybe the next few years, but it might be quite difficult to imagine how they can be built alongside other technologies that might or might not completely exist at this point. Okay? Having said that, I also think that AI is quite unique. Just like other technologies, it has, every technology is unique. I think two of the unique aspects of AI are, one, that it could be distributed. An AI system is effectively computer code. If I build an AI system, I could just send it to you, and then you have this AI system. If a company, say Google or OpenAI, builds an AI system and allows the world to use it through their browser, then effectively millions of people can use this AI system. There's a second way in which AI systems, I think, are quite different, is that they can help in decision making. In fact, they can even, to a certain extent, make decisions on our behalf. Take, for example, this autonomous cars. They're effectively driving on your behalf, making decisions about where to turn, how to go, how fast, on your behalf. And I think part of the excitement, but also part of the fear of AI is exactly in that. It is maybe the first technology that allows us to delegate some of our decision making. Okay, so let's move on and talk a little bit about how we can build and develop these modern AI systems. Okay, so maybe I'll just go back for one slide for 1 second. So when we build AI systems, the first step is that they must learn something, okay? To learn, we show them examples. This is what I have on this next slide. In the middle here, I'm using this icon of a computer as an AI system, and here I'm going to train this AI system to be able to do translation from, say, English on the left to French on the right. What I do is I'm going to show it examples, sentences of English, and then I'm going to ask it to predict the equivalent sentence in French. So I will need effectively data sets that are aligned of English sentences and French sentences. Of course, if I were to show it, 1 or 2 or 3 examples, it wouldn't really work, right? The system could only memorize. But if I show it enough examples, then the system can effectively figure out the type of regularities, right? Statistical regularities, you could call them, that allow it to translate completely new sentences from English to French. So we can build such systems. Of course, we'll need lots of data, but we can build such systems. Oops, sorry. And I would call such system narrow AI systems. Okay, these systems can do one task and one task perhaps really, really well. They can only do this one task. Okay, so in the example of my translation system, it can do translation. I think for about the last 5 years, evaluation shows that there are AI systems that can do English to French translation about at the level of an expert translator. Maybe it's not quite as good, but it's not too far. Okay, so we can build these very strong AI systems. But they remain narrow. This is in comparison to our human brain, right? Our human brain effectively allows us to do all sorts of tasks. Right now, I'm standing up, I'm moving my arms, and I'm speaking all at the same time, right? These are 3 things I couldn't do as a baby. Maybe I could just move my arms. Right? And so there's this idea of how can we build perhaps more versatile or broader AI systems. I think over the last year or so, we've seen actually examples, interesting examples, fascinating, I would call them even examples, of broader or more versatile AI systems. The screenshot I have here is of an AI system from a company called OpenAI. It's called ChatGPT. I imagine that, I see some nods. I imagine that many of you will have tried it. If you go to this website, you can interact with this AI system. This AI system is a chatbot or a conversational AI system. You can ask it things and you can carry out a conversation with it. Okay? It can do all sorts of things. It can't do them all very well, but in some cases it's very impressive. Right? So for example, things it can do that might be helpful are things like summarization. You can give it a text and say, summarize this text in 200 words. And it could sort of do that. It could sometimes pull out facts. You could ask it about particular concepts, about, say, what is ODR, and it might have a reasonable answer for that. It could do other things like make a content strategy, suggest some names, and so on and so forth. Right? The point of the system is that it cannot only do a single task, it can actually do a number of tasks. Well, the question is, how can we build such AI systems, right? So if you take the narrow AI approach, you can say, well, I'm just going to train it to do task 1, and then task 2, and then task 3, and so on and so forth. That seems very cumbersome, right? If I wanted to do 1,000 tasks, I'll need lots of data on 1,000 tasks. So instead, we do something a little bit different here, which is this idea that I'll talk about next, which is called next word prediction. So what we do is we train the model to be able to predict the next word in a sentence, right? So in a sense, we train the model to be able to model English or French language. Okay, so for example, let me take an example. The sentence on top says, the quick brown fox jumps over the lazy dog. I would take the sentence, I would divide it word by word, and I would give as input to my system the previous words and ask it to predict the next word. So I have 3 examples. I would first give it D, and I would ask it to predict quick. So I would train it to predict quick. Then from the quick, I would train it to predict brown. From the quick brown, I would then train it to predict fox, and so on and so forth. Again, the idea is if I only have a small number of sentences, there's not much a system can do. But if I have internet-scale data sets, then it's possible that a system can learn regularities and be able to do this task. So this is in fact what companies such as OpenAI and Google do. They download the whole internet, right? So that's trillions of words or trillions of sentences, and then they use this, they take every sentence and they train their system to predict the next word for every sentence. Okay? So that's step 1. So to build these more versatile AI systems, we use this idea of next word prediction. Then there's another step. So there's lots of biases on internet web pages, right? So if I'm just to download the whole internet and just train from that, there's lots of things that the system might not be able to do. So in the second step, what people do is called human alignment. There's different techniques for doing that, but I won't go into these details in this talk. Okay? So in human alignment, the idea is that I'm going to train my system to respond a little bit more like a human would do. Okay, so we're going to take an example here on the left. The example I give it is to create a shopping list from this recipe. So I have this recipe that says, trim the ends of the zucchini, cut zucchini in half lengthwise, and so on and so forth. And I want it to be able to pull out the ingredients of this recipe. Okay, so as a human, what we would probably do is read the recipe, say from top to bottom, and every time I see something that I can buy at a grocery store, I would pull it out and add it to my grocery list, effectively. If you ask an AI model here on the top right to respond, so an AI model that was just trained using next word prediction, it might do it, in this particular example, it actually tells you how to cook this recipe, right? This is likely because online, when you're told how to do a recipe, the next step is how to cook this recipe, right? It's the sort of next steps in making this recipe. But of course, what we've asked the model is to create a shopping list. So we would, if a human was asked this task, it's likely the human would give, here's the list of the ingredients you would need, right? Zucchinis, beef, onion, mushroom, peppers, cheese, ketchup, salt, pepper. So in this second step, we are going to gather lots of these human responses, right? So we're going to show humans these particular questions, like create a shopping list from this recipe, and then we're going to train these AI models to be better aligned with the human response. In this particular case, you can see the result on the bottom, right? It's not perfect. It still tells you how to bake it, but at least it's got then an itemized list of items you can buy at the groceries, and even has quantities, right? And I think some of them at least seem to match what the recipe asks for. Okay, so in the past couple slides, I've talked to you about one of the core ingredients of these modern AI systems. That is data. For both narrow and more versatile AI systems, we're going to need lots and lots and lots of data. And of course, it's going to depend on how much data we need, depends a lot on how complicated or complex the task is. If we want the system to learn a very complex task, then we're going to need more data. There are also two other ingredients that have been extremely helpful and critical in getting AI systems to the point where they are now, is hardware. So basically faster and better computers, but not just generic computers. There's actually computer chips that are now designed just to do the sort of mathematical operations that are required by these modern AI systems. These are called, for reference, graphical processing units, or GPUs. The third thing is actually open source software. So this is often, I find, overlooked, but it's something that I have found, for example, in my research, to be critical. When other researchers in other parts of the world build their AI system, they often will release the code, which means that I don't have to start from scratch. I can start from what they've done and improve upon it. This is true for code for systems, but also for things like libraries and APIs and other things like this, even programming languages, right? And so all of this sort of sharing of knowledge, I think, has allowed us to go much, 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 much faster, right? There's been a huge gain in efficiency. Maybe to give you one quick example, what would take me a week to do as a graduate student back in 2010 now can be done in about 30 minutes, just because we have better software for these AI systems, right? And these software are mostly open source. Okay, so I'm going to now try to project to the future and think about where some of this might be heading. Before we look at the future, let's look at the present. Let's try to think of what we can do with these AI systems. So in the previous part, I said there's really these two types of AI system, the more narrow AI system and the more versatile or broader AI systems. For the more narrow ones, of course, you will if you want to use them in your organizations, in your group, in your companies, you will often need to train them yourself, which means that you'll need to have access to data, for example, translation data, that's what you're interested in. And then you're going to need to be able to train these systems with your data. So you might say, well, okay, so maybe the more versatile AI systems, they seem interesting, right? Because they do all sorts of things for me. This might be true to a certain extent, but then evaluation of these AI systems becomes extremely difficult, right? There's a few reasons for that. First, we believe they can do some tasks fairly well, but which task exactly can they do, which tasks they cannot do, and how well they can do each task, that it really remains to be seen. Further, evaluating how good they are often takes a human, right? If I want to see how good a system is at translation, it's something that's very hard to do systematically. Typically, I will need to have an expert human, like an expert translator, to look at the output from my model and basically say, yeah, this is very good, right? 5 out of 5. Or this is not so good, 4 out of 5, right? And even that, there's lots of subjectivity. So the cost of evaluating these AI systems systematically is extremely high right now. I'd say, overall, there's maybe 2 main use cases for some AI system across domains. One, improve existing system. You could imagine that you have a simple rule-based or heuristic. You say, when the user writes this, then respond this way. So this is a sort of system that might be improved through AI. And there's also whole new systems that you could build to, with some of these AI tools, right? And I think I was looking at some of the discussion from this afternoon, and I think something that's been done here called the Justice Bot, that's the name, right? I think that's a good example of a new system, right? A new way to access, in this particular case, legal information that was not available before. Okay? So where might these systems go? I think often right now these AI systems sort of exist in a particular vacuum, right? So you can access them, right? Maybe I can use them to generate images and videos. Maybe I can use them to chat, right? But they don't connect to the rest of the world. They don't know how to use other tools that are very helpful to us humans. Okay? Further, one thing is, once I've trained my AI system, then it only knows about the world until it only knows about the data it's seen. So to give you a precise example, imagine that I am OpenAI, and I train an AI system with data up to 2020. And the system does not know about anything else than what happened until 2020. It does not know about 2021, 2022, nor 2023. Okay? And so this is where you'd like to be able to connect some of these AI tools to other tools we have, such as search engines. I ask something to ChatGPT. Okay, what happened? What are the newsworthy? What happened in the news this week? The AI system realizes, we're going to anthropomorphize it a little bit here. Realizes that asking a question about current event, does a Google search, obtains some results, summarizes them, and gives them back to me. Okay, if you actually use the latest versions of Bing, which is Microsoft's search engine, it actually is integrating already a search engine with their equivalent of ChatGPT. Okay. Imagine travel booking, right? Travel booking, you say, I want to go to France next month, roughly these dates. What does that mean? As a human, it means, well, I'll probably have to find a ticket, right, transportation, find a place to stay there, find activities to do, book them in advance, likely, right? And, there might be some fun in doing that, but if I had an AI system that could search on all these websites on my behalf and say, here are 3 trips or 3 options for this trip, pick one, and then maybe I'll ask you a few more questions, right? Sort of like maybe a travel agent would do. This might be extremely helpful. Think of your emails, right? We can take this traveling example again. I know I need to go to the airport tomorrow. I never remember the exact time of my flights or when I need to leave. So what I do is I search in my inbox, find the email with the plane ticket, looks at that particular airport, looks at the particular regulations in this particular airport at this particular time that tells me that I need to be there 90 minutes in advance. I have to factor in traffic, means I need to leave my house maybe 2 hours or 2 hours and a half in advance, right? You could think that an AI system that has access to my emails, right, could actually make sense of that, could search when my flight is leaving, could look at regulations, and could tell me, you should leave at about this time, right? This is, of course, only one use case. I think I just wanted to give you a few examples of some of the perhaps exciting use cases or applications of connecting AI with some of the other tools that we're currently using. Okay, so I've talked mostly about good things, but of course, AI is very far from being perfect, right? I talked a little bit about evaluations, but I'd say that although we've made considerable progress over the last roughly 10 years, there are still many immediate challenges that were not solved by current AI systems. There's a list, and I'll go through some of these with examples. Hallucinations is something that you might have heard of. It's been sort of covered over the last couple months in the news. The problem is that some of these AI systems sometimes make up facts. Okay? Here's a particular example. I asked ChatGPT to write a bio for Seamus O'Regan, who's, I believe, the current Minister of Labour, or the Canadian Minister of Labour. So it says things that are mostly correct, except at the end. It says that the last sentence says that this politician is married and has 2 children. When I actually did this, I was with the chief of staff of the particular minister, and the chief of staff said, that's not true. He does not have 2 children, and I can't remember about his marital status. Right? So what happened here? It looks like ChatGPT, in this particular case, made a sort of inference, right? It inferred, perhaps, that since many politicians in Canada are married, and maybe many have children, maybe 2 is sort of the average number, then this person, by virtue of being a politician, must be married and have 2 children. Sometimes making inferences about things you have not seen is very helpful, right? But sometimes it leads to these these factually incorrect pieces of data, right? These hallucinations. There's been lots of work over the last couple of months, but fundamentally how to solve this is not that easy, right? Because we do want it to make links between things that are sometimes not exactly related, but we want these links to be always correct, right? So one way to maybe around this would be to have some level of uncertainty, right? To say, well, I don't have any information that said that he's married, but lots of Canadian politicians are married, right? Maybe that would be one way around it. But ideally, if there's something that you're unsure about, you should probably not state it as a fact, right? That's sort of basic human communication, I guess. Okay, so hallucinations are a problem. Learning from the biases in your data. So these systems are only as good as their training data. If the training data discriminates, for example, against subpopulation, the AI system will discriminate at least as much, maybe even more. It can even amplify these biases that you have in your data. Here's an example that perhaps some of you know a lot more about. This was a system that was rolled out, deployed in New Jersey courthouses, that was supposed to help judges make an assessment about setting bail. Okay? And they were hoping that this system would not discriminate. Right? They deployed the system, and 5 years after, or a few years after, I believe, they sort of did a retrospective study, and realized that, in fact, this particular system discriminated as much as the judges used to discriminate before the system, right? Because the system was trained with this exact data, right? So it could just replicate the biases it had seen before. Okay, so it's not a silver bullet, right? If you give it biased data, it will reproduce these biased results. Here are a few more examples. The next example is a system that is asked to generate images, and we're asking the system to generate an Indian person. In this case, the system is very happy to generate this particular Indian person, always an old man with a beard, right? There are other examples of that. If I ask it to generate a CEO, white man in a suit, if I ask it to generate a nurse, very different demographics and very different genders, right? So it's Of course, if you think about it, you'd say, oh, it only reproduces what it is seen online, right? But if we are to use these systems and deploy them at scale, these are biases and let's say racism that is simply, we can't allow. We cannot use system with such biases. Other limitations, models can be difficult to understand and interpret, and evaluation is challenging. This is something, I don't have new examples for this. This is something I've mentioned before. I just wanted to reiterate. These systems are very, very big, right? One way to understand how big they are is to think of how many parameters. Parameters effectively the things we change when we train them. They have often billions or hundreds of billions of parameters. And so understanding them is a little bit like trying to understand a human brain, right? It is very difficult. And so if a system makes a wrong decision or a wrong prediction, it is often very difficult to understand where is this prediction coming from. Data privacy, there's, I think, obvious examples. Some of these AI systems are currently built by a small number of companies. To be able to use them, I must send my data to this third-party company, right? There's lots of use cases where that is simply not possible. I'm a hospital, I'm probably not going to be allowed to send my, say, patient data to OpenAI's ChatGPT. There's something else that can happen, is we often think of data as either you have this data or you do not have this data. But in AI, imagine I've trained my AI system with a particular set of data, then I don't know, does my AI system contain this data? Can I unlearn some of this data? Can I remove some of this data from my AI system? If so, how do I make sure that I've completely removed it, right? Maybe I've removed a part of it, but not all of it. Maybe the system can still reason about some of this data that's seen before, right? So it's not sort of enough to say, okay, I've deleted the data from my hard drive. I no longer have access to this data. This data is now effectively encoded in part or in whole in my AI system. Finally, AI systems are environmentally hungry, right? This is something that is probably not good news when climate change is probably the biggest, one of the largest problem humanity has to face currently. To give you particular examples, on top here you have a table that I pulled out from a recent publication. This is an estimation of how much tons of CEO were required to train GPT-3. GPT-3 you can think of as a precursor to ChatGPT. So around 500 ton was estimated that it took to train GPT-3. Of course, this will depend a lot on the type of electricity you're using, right? Is it renewable or is it from non-renewable sources? I think in this particular case, it's from mostly non-renewable sources. That's why it might be so high. But to give you an idea of 500 tons, one ticket from Montreal to Paris, if you were to fly from Montreal to Paris, is approximately a third of a ton. And so training GPT really requires 1,500 tickets, or one-way tickets from Montreal to Paris, right? So and this is one particular model that's just a training phase. When you use it, of course, it's extra CO2 emissions through the electricity it's using. And it's likely that companies are not training a single model, right? To get to this end model, they must train many, many, many more models, okay? So there's reason to think that maybe these systems will get more efficient, right? Just lots of technologies do get more efficient through time. But the AI ecosystem is also growing, right? We want to use some of these AI systems. Lots of companies are seeing use cases for them. And so at least a number of users will likely continue to grow. Okay, some concluding thoughts. So I believe over the last couple of years, what we've really seen and why we're talking about AI is that it's because it's becoming useful. No longer is it a thing that is built by computer scientists in their labs and then talked about at a computer science conference. It is now something that can have a broader impact in the world. Our hope is that lots of these usages of AI will be beneficial, right? We're hoping it can play a role in solving some of the world's biggest challenges. Think Think of climate change. Think of maybe discovering new drugs to be able to fight new illnesses. At the same time, this faster than expected evolution might also be problematic. AI has always been seen as a dual-use technology, right? A technology that could be used for beneficial applications, but a technology that can also lead to damaging applications. I think until now, at least from the technologist's point of view, we sort of imagined that, real AI systems were still far away. But as these AI systems are evolving much more rapidly than we thought, we are maybe in a sense caught a little bit off guard, right? And so I think it's extremely important that we as a society consider this, right? It's no longer, I believe, the sole role of technologists to think of how we want to develop the next generation of AI systems. It's now the role of all of us as a society to think more holistically about where we want to go. What are the sort of applications we want from AI? What are the sort of applications we do not want from AI? I think concretely, some efforts in that direction are propping up through legislation. So I believe the EU has legislation around AI. I know a little bit more about Canada. In Canada, there's I think a proposed law called IDA or C27, which will attempt to legislate around some of these AI systems. And in particular, in the law, they talk about high-impact AI system, right? What these AI systems, what we can allow them to do and where we don't want them to do. What sort of guarantees do we want from these AI systems? So I think it's the beginning of the conversation. I remain optimistic, but I think a lot more cautious than I was 5 years ago, right? I remain optimistic because I see all the beneficial applications, but I also see potential problems with this technology, current limitations, but also upcoming limitations that we can't necessarily quite write out just yet. So on these notes, I will thank you very much for your kind attention. I'm happy to continue the discussion with Nicolas.